APIs are a critical part of modern applications, be it consumer facing, partner facing, or internal. APIs foster innovation in developer community, but at the same time they are quite vulnerable too. Why? Because the APIs are meant to expose something, and that something can be an application logic or can be your sensitive data. And because of this inherent nature of APIs, they are the hot targets for attackers too. So the Open Web Application Security Project's API Security Project offers certain guidelines related to API security. What are those vulnerabilities that have been mentioned in this document? And what are the guidelines related to preventing those vulnerabilities? Let's take a look one by one. So, the first one is broken object level authorization. And it says that APIs tend to expose endpoints that handle object identifiers, creating a wide attack surface level access control issue. Object level authorization checks should be considered in every function that accesses a data source using an input from the user. So, what is object level authorization? It is an access control mechanism that is usually implemented at the code level to validate that one user can only access objects that they should have access to. So the point says that every API endpoint that receives an ID of an object and performs any type of action on the object should implement object level authorization checks. That is what we call object level authorization. The checks should validate that the logged in user does have access to perform the requested action on the requested object. Failure in this mechanism typically leads to unauthorized information disclosure, modification, or destruction of all data. So, the point is how we can prevent this. And on that, the document suggests that implement a proper authorization mechanism that relies on the user policies and hierarchy. Use an authorization mechanism to check if the logged in user has access to perform the requested action on the record in every function that uses an input from the client to access a record in the database. Prefer to use random and unpredictable values like GUIDs for record IDs. Write tests to evaluate the authorization mechanism. Do not deploy vulnerable changes that break the test. The second common vulnerability in APIs is broken user authentication. So, after authorization, the second point to keep in mind is authentication. Authentication mechanisms are often implemented incorrectly, and that allows the attackers to compromise authentication tokens or to exploit implementation flaws to assume other users' identities either temporarily or permanently. And that compromises a system's ability to identify the client or user. And when that compromised, the entire security of your API get compromised as well. So how would you know that your API is vulnerable? It is vulnerable if it permits credential stuffing, whereby the attacker has a list of valid usernames and passwords. It is vulnerable if it permits attackers to perform a brute force attack on the same user account without presenting CAPTCHA or account lockdown mechanism. If it permits weak passwords, then it is vulnerable. If it sends sensitive authentication details like authorization tokens and passwords in the URL, then your API is vulnerable. And if it does not validate the authenticity of tokens, then it is vulnerable too. So all the common best practices, if your API is not following in its authentication mechanism, then it is definitely vulnerable for the outside attack. And to prevent that, the document suggests that make sure you know all the possible flows to authenticate to the API. Mobile, web, deep links that implement one click authentication, etc. And one must understand that OAuth is not authentication and neither is API keys. And when you are building the authentication mechanism, don't reinvent the wheel in authentication, token generation, or password storage. Use the standards that are available. Credential recovery, forget password endpoints should be treated as logging endpoints in terms of brute force, rate limiting, and lockout protections. Where possible, implement multi factor authentication, implement anti brute force mechanisms to mitigate credential stuffing, dictionary attack, and brute force attacks. And this mechanism should be stricter than the regular rate limiting mechanism on your API. Implement account lockout capture mechanism to prevent brute force attack against the specific users. Implement weak password checks. And remember that API's key should not be used for a user authentication. If you want to use API keys, then use them for client, application, or project authentication. In that way, you can prevent this broken user authentication vulnerability. The third vulnerability is excessive data exposure, and this is the most common one because APIs rely on client to perform data filtering. And since APIs are used as data sources, sometimes developers try to implement them in a generic way without thinking about the sensitivity of the exposed data. So, how much and what you are exposing, you need to be cautious about that. An exploitation of excessive data exposure by attackers is simple, and it is usually performed by sniffing the traffic to analyze the API responses, looking for sensitive data exposure that should not be returned to the user. Now, again, the question how we can prevent this excessive data exposure. So, the simple rule is never rely on client side to filter sensitive data. The second is review the response from the API to make sure they contain only legitimate data. Avoid using generic methods. And if you are the backend engineer, then you should always ask that who is the consumer of the data before exposing a new API endpoint. Classify sensitive and personally identifiable information that your application stores and works with, reviewing all API calls returning such information to see if these responses pose a security issue. And one can implement a schema based response validation mechanism as an extra layer of security too. The next is lack of resources and rate limiting. Quite often, APIs do not impose any restriction on the size or number of resources that can be requested by the client or the user. While API requests, as we know, consume resources like your network, your CPU, memory, and storage. And this consumption not only impact the API server performance, but it often leads to and that leads to denial of service attack, but also open the door to authentication flaws like brute force. So we must consider the fact that requests from multiple API clients compete for resources too. And in that case, your API is vulnerable if at least one of the following limits that is mentioned in the document are set inappropriately. And what are those limits? Execution timeouts, max allocate memory, number of file descriptors, number of processors, request payload size, number of requests per client resource, number of records per page to return in a simple request response, and etc. And how we can prevent this? We know that Docker makes it easy to limit these certain limits that have been mentioned in the document. Implement a limit on how often the client can call the API within a defined time frame. Notify the client when the limit is exceeded by providing the limit number and the time at which the limit will be reset. Add proper server side validation. Define and enforce maximum size of data on all incoming parameters and payloads, like maximum length for the strings and maximum number of elements in an array. In that way, you can control this vulnerability. The next point is broken function level authorization. So, what is that? Complex access control policies with different hierarchies, groups, and roles, and an unclear separation between administrative and regular functions tend to lead to authorization flaws. That is called broken function level authorization. By exploiting these issues, attackers can gain access to other users' resources or administrative functions. So, the best way to find broken function level authorization issues is to perform deep analysis of the authorization mechanism while keeping in mind the user hierarchy, different roles or groups in the application. And to prevent it, the document says that your application should have a consistent and easy to analyze authorization module that is invoked from all your business functions. Frequently, such protection is provided by one or more components external to the application code. Your enforcement mechanism should deny all access by default, requiring explicit grants to specific roles for access to every function. Review your API endpoint against function level authorization flaws. Make sure that all your administrative controllers inherit from an administrative abstract controller. Make sure that administrative function inside a regular controller implements authorization checks based on the user groups and role. So these are the 5 out of 10 top security vulnerabilities in APIs as suggested or documented by OWASP, the Open Web Application Security Project. We'll discuss the other 5 vulnerabilities and their prevention mechanism in the next part. For more information on this, you can visit owasp.org and can locate their project API security. They have provided a detailed scenario based analysis of the situation and detailed prevention mechanism in their documentation.